welcome to Models and Agents, episode 39. It's May 3rd, 2026. Let's see what happened in the AI world today. And trust me, it's been busy. A Mistral AI launches a bang, a 128 billion model with remote agents and strong coding rates. Mistral AI released Mistral Medium 3.5 alongside remote agents and Vibe for async cloud coding sessions. They also introduced an agentic work mode in LeChat designed for structured developer interactions. They also entrust a 128 billion model quickly in Medium 3.5 and LeChat, designed for structured developer interactions. Just meth laughing now. The launch focuses on practical developer tools for building more autonomous coding workflows. Build intensity. Keep an eye on how these capabilities integrate into existing agent stacks this week. The big news today comes from Mistral AI with their new Mistral Medium 3.5 model. This 128 billion parameter flagship arrives together with remote agents in Vibe that support async cloud-based coding sessions. There is also an agentic work mode in LeChat for structured developer interactions. The combination targets teams building AI agents that need reliable coding assistance without constant human oversight. Developers can now run longer autonomous sessions on cloud infrastructure while maintaining control through the platform interface. The release marks a step toward more production-ready agent tooling from Mistral. Expect community experiments with the remote agent features to surface practical integration patterns soon. Shifting to other model updates, the CAISI report identifies DeepSeek V4 as the strongest model currently available in China. It still trails leading US systems by roughly 8 months according to the evaluation. The findings provide a snapshot of regional progress in open model development. Side-by-side testing on high-end GPUs found Chuan 3.6 27B and Coder Next performing similarly across many tasks. Coder Next delivered better cost efficiency on bounded document tasks. The 27 billion variant handled certain research-style queries more effectively. The comparison highlights how different architectural choices trade off consistency against efficiency. Local tests on M1 Max hardware showed Gemma 4 following formatting instructions more reliably for tasks like bounding boxes and Western cultural content. Chuan 3.6 performed better on video tracking and Asian context recognition, but it required strict 2 frames per second preprocessing for video inputs. The results underscore how training data geography affects real-world behavior. Tests across models from SD 1.5 through FluxDev, Twin Image, and Gemini evaluated photorealism, text rendering, and cultural accuracy on M1 Max hardware. Twin Image Lightning offered a strong speed-quality balance, while Flux led in photorealism. Cultural biases appeared more tied to training data origins than model scale. On the agent side, a new guide walks through constructing a multi-agent system for biological network modeling. It coordinates tasks across protein interactions, metabolism, and cell signaling simulations. Agents handle specialized subproblems in a modular way that supports complex scientific workflows. Developers working in bioinformatics can adapt the pattern for other domain-specific orchestration needs. Community discussion examines building FPGAs for models in the 20 to 30 million parameter range with quantization. They pair these with speculative decoding using fast, smaller models. The approach aims to deliver high token throughput at lower hardware cost. Questions remain around scaling beyond current limits and integration with existing inference stacks. A toy experiment demonstrates how a frozen Pythia 70 model can use forward-derived correction vectors for one-shot symbolic recall. This happens without any weight updates. The setup separates conflicting context meanings through learned retrieval geometry. It offers a lightweight path toward in-context adaptation that avoids full fine-tuning. In the practical space, a developer implemented a full GPT-style decoder-only transformer from scratch using only the C++17 standard library. That includes handwritten tensor operations, attention, and analytical backpropagation. The project trains on CPU with no external dependencies and includes an OpenMP accelerated version. The repo provides a clear reference for understanding every layer of a transformer without framework abstractions. On Hugging Face, the Chuen SAE Res Chuen 3.527 BW80KL0100 model provides a ready-to-use sparse autoencoder variant. It opens immediate access to mechanistic interpretability techniques on a 27 billion scale model. Users can load it directly for research into activation steering and feature extraction. Build intensity. A user built a Python agent via Claude that links Chuen 3.635b running in LM Studio to generate structured output. The agent reads input fields and produces a template for a 2025 tax return form without stopping until completion. It demonstrates quick agent scaffolding for domain-specific document generation tasks. Okay, let's pop the hood on this one and talk about tokenization drift. Everyone talks about model outputs as if they flow directly from weights and prompt semantics. But the first step of turning text into token IDs often creates hidden variability. Tokenization maps strings to a fixed vocabulary of IDs. So even small formatting differences like extra spaces, line breaks, or punctuation produce different sequences. These ID changes shift the initial embedding vectors that enter the transformer, which then alters attention patterns and can send generation down entirely different paths. In RAG pipelines, this shows up as inconsistent answers when the same query retrieves documents with minor formatting variations from different sources. The engineering trade-off is that strict input normalization reduces drift but adds pre-processing latency and can occasionally remove useful signals present in the original formatting. Production teams typically insert canonical formatting early in the data pipeline to keep behavior predictable. The practical takeaway is to always test critical applications against varied input styles rather than assuming semantic equivalence guarantees identical tokenization. If you want to get hands-on this week, test Mistral Medium 3.5 through LechCat work mode on a multi-step coding task. This will help evaluate the new remote agent capabilities. Run local vision comparisons between Chuen 3.6 and Gemma 4 using VLLM on your own image or video dataset. That will show which model better matches your domain. Set up the multi-agent biological workflow on a small simulation problem to practice modular agent orchestration. Clone the C++ transformer repo and run the CPU training example to see every component of a model implemented without frameworks. Load the new Sci8 Chuen variant from Hugging Face and experiment with steering on a few test prompts. Looking ahead, expect more real-world comparisons of vision models as local hardware and inference engines continue to improve. Additional hardware explorations around FPGAs and speculative decoding for cost-effective local inference are likely on the way. New fine-tuned and steering-focused releases on Hugging Face targeting popular base models should appear soon. Expanded guides for multi-agent systems in specialized domains like scientific computing are also coming. Click Gem46 to node, oct down. Before we go, Tomorrow, keep an eye on how developers are testing those FPGA approaches for speculative decoding and real inference setups. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy and I hope others do as well.